So a hydrate is basically a substance or a compound that has been consumed or is surrounded by water. And so with this in mind, we've seen hydrates before. This one is probably the one that we've used most frequently, BaCl2 with a dot and 2H2O. Remember, this dot does not mean multiplication, it just means that barium chloride is surrounded by water, so it's the hydrate of barium chloride. And each compound can form different hydrates, so hydrate 1, or monohydrate, dihydrate, trihydrate, depending on how many water molecules are surrounding it. So when we're looking at a hydrate, we have to know how to name them, and it's nothing new. So I'm going to use this one as an example. We first name the overall compound like normal, so barium chloride. And then we use the word hydrate for the water molecule, and we add a prefix at the beginning to describe what coefficient is present. So since this is 2, we would put dihydrate. And we use the same prefix patterns that we use with covalent compounds. Mono for 1, di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, we don't really use 9, and then deca for 10 water molecules. So now that we know what a hydrate is and how to name them, we also need to understand what anhydrous means. Anhydrous, of course, if you're hydrated, that means you contain water. If you see an in front of it, it's the opposite. So this just means without water. So in your word problems that we will be working with, you can see something that says the hydrate of copper 2 sulfate. And this just means that it's copper sulfate surrounded by some number of water molecules. Or you can see the anhydrous of copper sulfate, which just means you are looking at copper sulfate alone with no water in it. Okay? And so when we are looking at these, we see specific examples. It either can be word form or it could be just giving you percentages. But a lot of the times you will not know the actual coefficient here for water, and so we have to solve for that specific coefficient. So let's see the shorter version of them giving you the ionic compound and you looking for the coefficient. I'm going to use this barium chloride example. So they would say that you have 5 grams of a hydrate of barium chloride. And after heating, the anhydrous, or the barium chloride without water, is equivalent to maybe 4.26 grams. So that means that if I'm looking for how many water molecules there are, I'm going to have to take the substance with water and subtract the substance alone just to find water by itself. Okay, and when we do this, we get 0.74 grams of H2O left. Okay, and we will see this in a hydrate lab that we're doing, where you can drive off water and then check the masses and see how much water was actually present. Okay, so from here, to find out how much water is present in this overall compound, I am going to use percent composition. Okay, And so with percent composition, I have to do it for barium chloride and I have to do it for hydrogen. So I know that I have 4.26 grams of barium chloride, and the first thing we do is we convert it to moles. 1 mole of barium chloride goes on the top, and then we're going to put grams at the bottom. So remember, barium has a 137.33 mass plus 2 times 35.45 for 2 atoms of chlorine, which gives you 208.23. So I'm going to take that 4.26 and divide it by that formula mass, and you get 0.0205 moles. And then we do the same thing for water. I found 0.74 grams of H2O, and I want to convert it to moles of H2O. So I'm going to take the mass of water, which is 18.02, and grams will cancel out. And when I plug this into my calculator, I get 0.0411 moles. So now we divide by the lowest amount, and I know I said that we were doing percent composition. I do apologize about that. We're using empirical formula, and so of course the second step of empirical formula is to divide by the smallest amount, which is 0.0205. So this is going to be 1. And when I multiply water by 0.0205, we get 2. So that means this is a 1 to 2 ratio. For every 1 compounds, or for 1 unit of barium chloride, I'm going to have 2 molecules of water. So I fill in these two as coefficients. 1 barium chloride, and it's surrounded by 2 water molecules. Okay? So that's usually the shorter version using empirical formula. Occasionally, however, you're going to get problems that don't even give you the ionic compound put together. So let's look at our unit sheet. Let's look at number 19. I have 25.3% copper, 12.9% sulfur, 25.7% oxygen, and 36.1% water. So we are going to use our empirical formula to find out how all of this is going to piece together and in what ratio. So 25.3% of copper becomes grams of copper. 12.9% of sulfur becomes 12.9 grams of sulfur. 25.7% of oxygen becomes grams of oxygen. And then lastly, 36.1% becomes grams of H2O. So now let's convert it to moles. We know copper has a 63.55 gram formula mass on the periodic table. And so then converting that to moles, we take 25.3 divided by 63.55, and we get 0.398. And remember to avoid rounding until the very end. You usually want 2 to 3 decimal places. Alright, convert sulfur to moles using 32.07 grams of sulfur from your periodic table. And you should get 0.402 moles. Oxygen we convert to moles using 16 grams of oxygen from the periodic table. And you get 1.61 moles. And then lastly, we take 1 mole of H2O and put it over the formula mass, 18.02 grams of H2O. Grams, of course, will cancel out, and when you plug that into your calculator, you get 2.00. And so the second step of empirical formulas is dividing it by the smallest amount, which is 0.398 moles. and moles will cancel out. Right, so we get 1 for copper, and then we also get 0.402 divided by 0.398. You get 1.01, which now we can round to 1. You can get 1.61 divided by 0.398, and you get 4.04, which is close enough to 4 that we will round to 4. And then we have 2 divided by 0.398, and we get 5.02, which is also close enough to 5. So now we just put these as subscripts, and then of course the water molecule is already put together, so this is its coefficient. So I have 1 copper and 1 sulfur for every 4 oxygens. And then since I see water is present, I put the dot for the hydrate. I have 5 water molecules that are present. Okay, so now you can see the 2 different types of problems you can get. You may have to put the entire hydrate together, or they may go ahead and give you the equation and you just solve for how many water molecules are present. So hopefully this helps. Definitely look at numbers 19 through 22 right here on the unit sheet and use it as practice. And if you have any questions, come see me.